Hello everyone. In this video, we're going to look at another data cleaning example. Again, we're going to see some missing values in this data set and we're going to deal with it. The difference between this video and the previous one is the fact that the type of missing value that we'll see in this data set is a little bit different than the one before, and it's going to be handled differently. So let's look at this example, which we will spend time cleaning and then we'll look at the missing values. So in this video, we are going to work on electricity data. This data is collected from electricity demand in the country of Belgium. So the first thing we'll do, we import our modules we're going to be using. So these are our modules, and the data set is part of the data set, the electricity data from 2017 and 2018. So once we read this data, we see it has three columns. It has date, time, and consumption. We can see that the way that the data is collected here is every 15 minutes the demand or the consumption of electricity has been recorded. These types of data are known as time series data. So let's get to know the data. I'm go through those steps that we always go through any data set. So we want to understand the data a little bit better. So we look at the shape of the data. This tells us the data has 36,742 rows and 3 columns. You could see the 3 columns, but we were not able to see the 360,000 some rows because there are so many, and then we were using the function df.head. So let's go ahead and calculate the statistical measures of the only numerical attributes this dataset has: consumption. So once we use the function describe, it calculates the mean, standard deviation, minimum, maximum, and all the percentiles. And we start getting to sort of a sense of the data. We see the mean is around 56,000 with standard deviation of 12,000. So this is the metric way of getting to know the data, but we could have done this using two visualization, histogram or box plot. So if you do the histogram, we will see the same sort of information. Around 50,000 is our average, and we have some standard deviation, but here we also get to see that our data is skewed towards right, and there is a higher tendency toward left of this range of the data. And if you do the same thing with box plot, we see similar thing that towards the bottom part of consumption there is more congestion of data happening there. And we can also see that there are two flyers in this data. There are different ways you can draw the box plot. This is one of them. We can just use the pandas data frame, say plot con box plot, or we can just say box plot. It's going to plot the same thing for us. Or we can use from the matplotlib the root and say plt.boxplot and then pass the data we want to be drawn. So let's remove this drop in A for a second. Once we run this, it gives us an error, and the reason is because this data has missing value. So for us to take care of that, to be able to use this function, we drop all of the missing values first, and then we pass the consumption. So we'll be able to see the chart. So what this tells us is the fact that the pandas box plots drops the missing values first before plotting these values, plotting these charts. So now let's do some data cleaning. First and foremost, we have to understand what's happening with our data. What is the structure of the state? How many rows are here? Do we only have data for 2017, 2016, 2018? And all of those things we want to figure out and then clean the data based on those things. So here, first we want to focus on the date. First we wanted to we want to only work on 2017 data. So anything that is not 2017, we have to remove. And then we want to check if the data is, formatted in the US or European style. So first thing we will do, we will sort of split the date column, and it's split by the slash because that's how the date is formatted. So once we do this, now we'll have a new data frame, but since we don't know which one is month or day first, we don't know that yet, we're just sort of calling them month or day 1 and 2. We don't know if this is month or this is day because it's a data from Belgium. It could be European style or US style. So we just keep them like MD1 and MD2 for now, and then we'll figure them out later. So one thing we do to check out if we have other than 2017 data, we use the function unique. So we say, I want to know the unique values that are in this column. So once I run this, now I have 2017 and 2018, and only I want to have 2017. So everywhere that I have 2018, I want to drop, or I want to only keep the ones that are 2017. So how I could go about this is I could sort of like update my data by this Boolean mask. I just say I want only to keep the date df and electricity df that are 1 for this on this Boolean mask, because the Boolean mask is created for only the ones that have 2017. So once I run this, now my data is does not have 2018 anymore. So if I say unique, it's only 2017. It doesn't have 2018. So one question that's been asked here: why did they do this for date df and also for electricity df? Think about this for a minute before continuing to watch this video. The reason is these two data frames are sort of mirror of each other on the rows. They have the same number of rows. And we are sort of working on the date df separately, but we are working on this data frame because we are interested about the electricity df, which is the main data frame. That's why whatever we do for this one, we have to also make sure that it's been reflected on the other or the main data set as well. So now we get to check about MD1 and MD2. So let's go ahead and check. MD1 is unique values are from 1 to 12, MD2 is from 1 to 31. And it is obvious that MD2 is day and MD1 is month. So after all, the dates were formatted in the US style. So it's month, day, and year. So we go ahead and change that, and then we join the month, day, year, date data frame to our main data frame. Once we do that, now not only do we have the date, we will also have the separate month, day, and year to our data. So another problem here, we want to add a weekday to this data. As in, we have the day and the month and the year. We also want to know what weekday this consumption was recorded in. So think about this and give it a try before continuing to watch this video. So the way you go about this is you will create a function that based on the month, day, and year, it sort of like tells you the weekday. And then you apply that function to this data frame. And then you get the new column that tells you about the weekday. So there is a function that does this for us from the module datetime. So we import this module and we use that to return which day of the week this row is. And each row has a year and month and a day. So we are assuming that we are going to apply this function to this data frame. And since we are going to apply to each row, we know a row is going to come in here. So I know that the row is going to have a year and a month and a day. And I switch them to integer. And then I use this function from datetime module. and then I get the weekday, and I know the weekday codes are 0, 1, 2, 3, 4, 5, 6, and I want to make them into those 3-letter weekdays. So I go ahead and use some conditional to make sure that I'm getting those values. So I create this function. Now I go ahead and apply this function to my datedf, and I make sure that the axis is 1, which means that I want to apply this function to my rows. So once I run this, now I have created a new column that are mirroring the data frame, but it's showing the weekdays for each row. And I go ahead and join this new column to the data frame. So once I run this, now I will have a weekday to my data. So finally, before we get to the missing value, we want to understand what's happening in this this column type. Do we need all of these values or not? So let's go ahead and split this based on the colon and see what's happening there. So we know that the first one is hour, and then there is minute, and there is a second, and then we sort of check if the unique values of each of these, and then we'll see, as we expected, that the second doesn't really change. So we can go ahead and drop the second because it's not adding any value, or it's not adding any information. So we drop that, so we only have hour and minute, and then we go ahead and also add that to our data frame. So we have hour and minute, and also let's go ahead and have another attribute here that sort of put the hour and minute together. So if we want to do that, we can create a lambda function that put those together, hour and hour.minute, and then sort of create that, and then we have that column in our data frame. There we go. So hour and minute, hour and minute. So now that sort of we have cleaned our data, let's start working on the missing values. So first thing we have done here, we have created a function that is telling us, sort of like creates, that reports how many missing values are in your data. So first of all, we need to know how many data rows we have. So the first part of this function tells us how many rows of data this data frame has. And then using the function isNow, we count the number of true values. So the way we do that, this is going to give us a Boolean data frame that is like filled with Boolean, or it's going to give us a series that is filled with Boolean. And then we change all of them into integer. When you change a Boolean into an integer, it's going to change the false values into 0 and the true values into 1. And then we sum those all at once, and it tells us how many of them are actually missing. So once we run this, we now create this function. Now we can go ahead and use this function to get the number of missing values for this data. And we can see that a good number of missing value exists in data. So it's 35,000 rows, and we have 16,000 missing value. So once we know that the data set has missing value, what is the first step? The first step is to figure out why these missing values are happening. So the best way to understand that, of course, is to ask questions. Whoever has provided this data, or whoever knows more about this. But if you don't have that luxury, you still can use the data set itself to start investigating. The way we have investigated here, we basically have come up with the bar charts based on each of the category in the data, based on the month, day, weekday, hour, and the minute, to see if there is a specific pattern of missing values happening based on any of these categories. So what we have done here, based on each of these columns, we are creating a subplot, and we count the number of cases for each of the missing value for each of the possible values of these categories or these columns. So once we run this, now we see that the missing values are happening equally across all of the month, but month 12. Something might be going on here. But let's continue looking at the other ones. The day looks normal. I mean, most of the missing values, most of the days are the same, but for the 31st, there are less number of missing values, which makes sense because there are less 31st day of the month in the calendar. And then we look at the weekday. Everything looks sort of like spread out, so there is not a specific pattern. For the hours, the same. But for the minute, we see that there is an obvious pattern, and the missing values are only happening at 15 and 45 minutes. And then once we investigate further, we figure out at some point in the data collection switched from every 15 minutes data collection to every 30 minutes data collection. So this is definitely a case of MNAR, which means missing not at random. And because the data collection switched, now we know what's happening, so we go ahead and only drop the 15 of all of the 15 and 40 minutes. And once we do that, now it helps us to sort of like deal with these missing values. So we drop all of those, and then we check the status of our missing values. So after dropping those missing values, or making sure that we don't have 15 and 40 minutes values, it's only going to be the 30 minutes and the hour values. Now still we have 4 missing values. So we do the same thing. We see if there is a specific pattern for these 4 missing values happening. So we draw the same charts, and now we see that there are not many pattern here. So we do have 2 missing values for month 12, but it's only 1, so it could have easily happened by chance. Still for Monday or other days, so still there are not a pattern here. So we see that these 4 missing values are happening randomly across our data. So we assume that they are missing completely at random. So once we know that the missing values are missing completely at random, it sort of opens our hand a little bit better than not missing not at random or missing at random, to think about imputing them. So this is a time series data. And dealing with missing values for time series data is a little bit different. Actually, it's a little bit easier. So to understand why it's a little bit easier, let's go ahead and take a look at all of the missing values, the 20 points before and the 20 points after. So I have written this piece of code that actually does that. So it keeps all of the missing values in this data frame and goes through all of those 4 missing values, and then plot the missing values 20 points before and 20 points after those missing values. 20 points before and 20 points after those missing values. So once we run this, now we will see that the missing value that happens at index 167, we have values 20 points, and then at this point there is missing values. And you can see for all of these, since there are abundance of information around this occurrence of missing, you could simply actually estimate these missing values by the closest points to them, because we can see sort of that there is trends in these data, because the time series, the point right before and the point right after are the most important information for estimating this value that is missing. And Pandas simply can do that for you by doing an interpolation. Basically interpolates these 2 values for you and then finds a value in between. So basically you say that interpolate, and you specify your method that is linear, and then everywhere that you don't have a value, it's just going to interpolate for you, and then you have the f.consumption, which is the new column that's going to be shown for you there. So once I run this, now I can see those values are filled out and it seems that it's like there were no missing value never before. So it's been taken care of pretty nicely and without minimal bias added to the data. So we go ahead and check one more last time. You'll see now we don't have any missing values. So now that we don't have missing values and we have also cleaned the data, we go ahead and save that to our a new version of the data, which is a clean electricity data 2017. So once we run this, now our data is saved in a new file and it's clean and it doesn't have any missing values.